Hello friends, this video on equilibrium part 17 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Now let's try to find the relation between K, Q and G. We know that K is what? Equilibrium constant, Q is what? Reaction quotient, and G is the Gibbs free energy. And the relationship is this. Delta G is equal to G naught plus RT ln K. This is something which we have read in the last chapter also, and in equilibrium this is equal to 0, so the whole equation becomes 0, and with this we get this value. I'll tell you how. See, delta G is equal to 0 or delta G naught plus RT ln K is equal to 0, or what do you get? Ln K. Ln K will be nothing but delta G naught by RT minus, so K will be what? E to the power minus the whole thing, that is delta G by RT. This is what you get, right? And also as we have told that if delta G is less than 0 and K is greater than 1, reaction is spontaneous. G is greater than 0, K less than 1, it is non-spontaneous. So this is the relationship between K and G. The relationship is this. Just remember this relationship. If you get some numericals, you can just use this relationship to solve those. The relationship is pretty simple. If you know the value of delta G, then you can find the K, or if you know K, you can find delta G. Obviously you should know R and T, because K happens only at a given temperature, so if you know K, you should be knowing T also. Let's take some examples on this. The question says the value of delta G naught for phosphorylation of glucose in glucolysis is 13.8 kilojoule per mole. Find the value of Kc. So the question says delta G for phosphorylation of glucose in glucoses is 13.8 kilojoule per mole. We have to find the value of Kc. So delta G naught is given 13.8 kilojoule. I'll convert into joule per mole. I have to find Kc, right? So Kc, you can directly use the formula e to the power minus delta G by RT. So this will become e to the power minus delta G is what? This value, 13.8 into 10 to the power 3. R is what? 8.314 joule per mole per Kelvin, and this is joule per mole into temperature 298 Kelvin. So it gets cancelled. Per mole get cancelled, joule get cancelled. So what you are left with is e to the power minus 5.569. If you solve this, you get 5.569. Correct? So this is my Kc, and this is nothing but 3.81 into 10 to the power minus 3. Easy one. Just direct application of the formula. One thing to note here is, since I am taking the G in joule per mole, I'll take the R value to be 8.314 joule per mole per Kelvin. So the value of R that you should take should match with the value of G. Okay. Again, a pretty straightforward question. Hydrolysis of sucrose gives sucrose plus water gives glucose plus fructose, and the Kc for this reaction is given. Temperature is given. We have to find delta G naught. Delta G naught is very easy, is nothing but minus RT ln K. Put the value. So it is minus R is 8.314 joule per mole per Kelvin into temperature, that is 300 Kelvin, into ln K. K is what? 2 into 10 to the power 30. So this Kelvin gets cancelled. So what I'm left with is minus 7.64 into 10 to the power 4. And what will be the unit? It will be joule per mole. Joule per. That is the answer. So the question says we have to find the G0 and Kc for this formation of NO2 from NO and O2 at 298 Kelvin, where the reaction is given, where we have the delta G0 for N2, delta G0 for NO, delta G0 for O2. So first thing I have to find, you have to find delta G0 for the whole reaction, and then using the formula which we learned just now, we can find Kc. So let's find delta G0 for the whole reaction. So this will be nothing but delta G0 of product minus delta G0 of reactant. This concept is something which we learned in the last chapter. So for products I have NO2 only, right? That is delta G0 of NO2 minus sum of delta G0 of reactant, that is O2 and NO. So what is the delta G0 of O2? 1 by 2 into this guy 0, or I'll write it delta G0 of O2 plus delta G0 of NO. Correct? Let's put the value. Delta G0 of O2 is what? 52 kilojoule per mole minus 1 by 2 into O2 is 0 plus NO is what? 87 kilojoule per mole. So you solve there, you get minus 35 kilojoule per mole. So this is my delta G0 for the whole reaction. Okay, now I have to find K. I know delta G0 is nothing but minus 2.303 RT log K, or RT ln K, same thing, right? So instead of ln I'm using log, so I'm multiplying with 2.303. So what is delta G0? Minus 35 is equal to minus 2.303. R is 8.314. T is 298 Kelvin into log K, and this will be joule per mole per Kelvin. So you solve this, minus minus cancel, you solve the whole thing, you get K to be 1.361 into 10 to the power 6, and that is, this is joule per mole, minus 35 joule per mole. So everything gets cancelled actually. All the units get cancelled. I get K to be 1.36 divided by 6. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.